Hello, everybody. Welcome back to another installation of the iconic YouTube Red series, Thrizix. I'm your host, Mr. Thrasher.
Oh, sorry, I think I've been having a bit of tinnitus recently. Anyways, I'm currently in Yellowstone National Park on a government-sponsored mission fighting bears, so my setup may be a little bit different than usual. Anyways, this video is about buoyancy. We are going to be going over what buoyancy is, what equations are associated with buoyancy, and what it means for an object to float. We will also briefly talk about the Archimedes principle. This is what the equation for buoyancy looks like. It is F of buoyancy equals negative rho times G times V. Now to visualize this, let's say we have a cube in a pool, and this cube is in place, floating, but submerged in water. Buoyancy is used to describe an object's, like this cube's, ability to float when placed in a liquid such as this pool. The buoyant force is an upward force applied by the liquid that acts against the weight force of the object when the object is partially or wholly submerged in that liquid. Along with those forces, there are also horizontal forces due to pressure that don't affect whether the object floats or sinks, because the horizontal vectors don't affect vertical vectors in any scenario. And that's what the free body diagram would look like. To further explain the equation, we can start by writing the sum of the forces on the cube using Newton's second law. It would be the force of the bottom subtracted by the force at the top of the cube. And the forces exerted on any objects in a liquid is equal to the pressure multiplied by the area. So we can expand that by saying those forces are equal to pressure times area. And the pressure can be expanded by saying pressure is equal to density, which is represented by a Greek letter rho, which is not lowercase p. Lowercase p represents momentum, multiplied by g, which is negative 9.8 multiplied by h. And the g in this line explains why the initial equation is negative, because g is negative 9.8 on Earth. And the only thing that makes a difference between the force acting on the bottom of the cube versus the force at the top is the height, because the height at the top of the cube would be less than the height at the bottom in relation to the entire pool. And when writing the expanded equation, since the variables for rho, g, and area are the same at the bottom and at the top, we can factor them out. So we would end up with rho times g times area, which would be multiplied by the difference in height. And we know that area multiplied by difference in height is just the volume of the liquid displaced, which brings us to the final buoyancy equation. Rho times g times volume.
Oh, crap, guys. I'm sorry. There's so much malaria. I really don't think I'm gonna make it, but for the sake of physics, I have to keep going. So, now, that brings us to the Archimedes principle. What is that? Well, let's start with this. We've already established that the equation for buoyancy is rho, density displaced, density of liquid displaced by an object, times g, which is the acceleration due to gravity, times volume of liquid displaced by the object. But what is density? Well, density is actually measured by m over v, and in this case, it is mass of liquid displaced over the volume of the liquid displaced. When we insert that back into the equation for buoyancy actually becomes m over v times g times v. And you'll notice that these two volumes are exactly the same. They are both volume of liquid displaced by the object, so they cancel out. And that makes the new equation actually just buoyant force is equal to mg, which we all know is equal to weight. This is what the Archimedes principle is telling us, that the buoyant force is actually equal to the weight of the liquid displaced by the object submerged. What can this tell us about flotation? Let's define flotation. We know we can use Newton's second law to figure out how an object flows. So Newton's second law, force, sum of the forces on the object submerged or partially submerged in liquid equals ma. The object is floating, therefore it is at rest. Therefore, the sum of the forces is equal to 0 because the acceleration is 0. The sum of the forces is the weight of the object minus the buoyant force. And from the Archimedes principle, we know that I'm going to change colors here. We know that the buoyant force is equal to weight of the liquid displaced, which means that in order for an object to float, the weight of the object must be equal to the weight of the liquid displaced. Wow. And then if these two forces become imbalanced, say the weight of the object is now greater than the buoyant force, the object will start to sink. Wow. Well, that's all for me, team. I'm going to try not to die of malaria, and
Thank you for tuning in, team. That was quite a ride of a video. I think I'll get my tetanus cured soon, so don't worry. Goodbye.